Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central, and I'm also the Chief Data Scientist for Data Magnum. Now, I'd like to start off our event today by thanking Alteryx for sponsoring today's event. Alteryx is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled Breaking Barriers to Insight by Revolutionizing Your Analytics, and that'll be presented by Alteryx. But before we begin, I'd like to briefly review the format for today's webinar. Today's event will be an hour long. We have three presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Raman Kaler with Alteryx, Hasan Hboubati, also with Alteryx, and John O'Brien with Radiant Advisors. Now, Raman is Senior Manager, Alliance Marketing at Alteryx, where she focuses on defining strategy and executing joint marketing programs with key strategic technology partners. She currently focuses on alliance marketing efforts with, amongst others, Amazon Web Services, Microsoft, Salesforce, and Tableau. Raman has proven success in creating strategic marketing and business development programs that drive and support pipeline growth. Now, Hasan is a solutions engineer at Alteryx, where he empowers customers by helping them to get insight fast. Hasan teaches data science at the University of California, Irvine. He has hands-on analytic experience and was instrumental in launching various analytic practices in the Orange County and Los Angeles area. John is Principal Advisor and CEO at Radiant Advisors. With over 25 years of experience delivering value through data warehousing and BI, John's unique perspective comes from a combination of his role as practitioner, consultant, and vendor CTO in the data industry. As a recognized thought leader in data strategy and analytics, John's been publishing articles and presenting at conferences in North America and Europe for more than 15 years. So today, John provides research, strategic advisory services, and mentoring that guide companies in meeting the demands of next-gen information management, architecture, and emerging technologies. So Raman, Hasan, John, hey, we're very pleased to have you with us today. When it comes to breakthrough analytics, it's vital that the various components of your ecosystem, analytics, data science, cloud, databases, etc., work together like well-orchestrated ensemble. However, ensuring this is not always the easiest of feats. We know it can be the wild, wild west of data out there. Organizations' objectives vary, and the pressure of architect and the right system is further exacerbated given the significant investment that goes into analytic infrastructures, time, people, and money. So in today's Data Science Central webinar, we feature Radiant Advisors, experts in selection, deployment, and optimization of data analytics technology, and their recommended best practices for choosing and deploying a modern analytics ecosystem, such as Alteryx with Amazon Web Services. Learn how you can revolutionize your analytics and deliver the capabilities, efficiencies, and stability needed to tear down yesterday's barriers to insight. So John, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Great. Thank you, Bill, and I hope everybody can hear me well. Good morning. I will get started here just with a quick background. Bill did a great job on my background, so I'm only going to take one moment here. And what I wanted to emphasize here is that Radiant Advisors, as an independent research and advisory firm, we do specialize in building data and analytic strategies for companies, and typically this is around modernizing their data and analytic platforms. This is one part with the technologies, architecture, but it also includes the people and processes that we're going to talk about here today. This webinar and the corresponding white paper that will come out from Alteryx shortly after this webinar are based on years of research that we have been working with this with a number of our own clients, our network of companies that are Fortune 500 companies, and we study the success factors, the lessons learned, the processes, and the technologies that really sustain modern analytics in these companies. Their goal is to grow the adoption and make data analytics widespread throughout their enterprises. So this is where we spend our time. And once again, 25, 30 years, I have been doing this primarily throughout my entire career with just multiple different perspectives and enjoy sharing that with as many companies as we can. So for today, what I would like to do is to break up my portion of this presentation into two sections. The first one, I'm going to talk about modern data strategies or modern data platform, and I'm going to give you just kind of a high-level overview of how we approach modern data platforms and the technologies that really become the foundation for enabling a modern analytics strategy. We're going to refer to this as our modern analytics lifecycle. This is what we've seen time and time again as what works and what's more importantly needed within companies. For this aspect, we want to make sure the requirements that support a modern analytics strategy is accounted for within the modern data strategy itself and the data platform architecture. So we'll go into what is this modern analytics lifecycle we talk about. And then for today's presentation, one of the main things we're discussing today is we can talk about a modern data platform, we can talk about the conceptual architecture, a logical reference architecture, but then we're going to go one step deeper into a physical, or what does this look like on Amazon Web Services. So what is the AWS reference architecture for the modern data platform? And then what is the AWS modern analytics lifecycle look like for those of you who are already in AWS or looking to migrate that and are looking to consider how we do this? This is what our presentation is going to be broken down by. So with that, why don't I go ahead and jump right into our conceptual architecture. So for us, driving enterprise analytics is about driving three core competencies within the enterprise. What we're talking about is traditional, if you will, business intelligence and reporting. This far left-hand side emphasis in our diagram here is not going away. It is still very much needed in every enterprise as a part of running the business, knowing what our goals are, knowing what our metrics are, and about managing performance management in the business. Of course, today on the right-hand side, we see quite a bit of value being generated, insights, and emphasis on the data science in the AI world. This is where we take analytics to a whole new level with data science algorithms, statistics, AI routines, all of this stuff that really is going to exploit data in new ways. And right in the middle there, truly what has become in the last couple of years recognized as a core competency within the enterprise is enterprise self-service data analytics. The ability to enable business analysts and data scientists to get into working with data, doing their discovery, doing their profiling, doing their exploration, making sense of that data, making something very quickly. When you put that capability in a business user's hand that has context and has intent to tackle projects very quickly and then flush them out and deliver value to the business. This is slightly different than the other ones because in business intelligence we have metrics which are typically predefined by the business, their calculation, their components, including their data needs. All of this, though, we believe today is being run on a data foundation and, at a minimum, the enterprise data lake. So logically, this enterprise data lake includes raw data, curated data, meaning data that's been defined and cleaned up and made available for others to use, as well as processed data, can all live within this data lake for reusability so that work that any one of these three competency areas are doing can leverage each other's work. And that's all fed by a data engineering or data platform team that can take care of modern data integration, which is based on streaming data ingestion and engineering data pipelines. And at the bottom there, all of your data can come into this platform and be made available for all three competencies areas. So when you have a conceptual architecture that is built to deliver enterprise analytics, what this translates to is a logical reference architecture, which we describe taking that same concept and breaking it down as data flows from left to right in this diagram, all of our sources of data, internal systems. We talk about database replication there for change data capture and real-time streaming, software as a service providers as other sources of your data with their APIs, and then a lot of files that are getting sent or acquired from third parties that you may purchase, partners that you're working with, and lots of public data and user data, which can be included into our file ingestion. The heart of the data ingestion and data pipelines is the streaming data hub. So this data streaming hub is where everything comes in, and all of these channels or topics of data are made available to various pipelines that can be engineered to deliver data into that central blue modern data platform. The modern data platform, and once you get into a lot more detailed research and data management principles and all of the architecture, really for us breaks into three categories. At the top, we call it our reference data class. Traditionally, enterprise data warehouses live here, or mastered reference data lives here. Our analytics optimized class. These are database engines that have been optimized for analytics, whether they're NPP columnar databases for high performance in database processing or large big data sets. Graph databases are also have been around and offer relationship analytics. Or even if you go back 10, 20, 30 years, traditionally our OLAP cubes are another form of analytics that were optimized inside of these cube databases. And then at the bottom we have our flexible processing class, and this is where the enterprise data lake lives, and typically they are object stores. They're on the cloud, they can be on premises, but the idea here is you can bring in data and files, store them, and figure out the schema later. So this is, we'll take files, structured, unstructured data, anything that you would need to drive your business analytic capabilities on the right-hand side. And there we have business intelligence and reporting for business performance management, data visualization and BI platform servers, support development there, self-service data analytic platforms, work with the whole modern data platform in that middle section with client development and their own gallery tools for data reusability. And then finally in the bottom we have our data science and AI category, which today is being done quite a bit on Apache Spark clusters, or perhaps traditionally you have some statistics servers and software, or you're making some of your data science and AI routines available to applications via API gateways. So here we have our data pipelines and ingestion, driving a modern data platform that can then enable enterprise analytics, and these represent the logical data flow of those. So when we go to our next step, and what our presentation here is also about, is around AWS. So what if you want to take this logical reference architecture and this conceptual approach that we have and apply it to AWS? This is what it starts to look like. This is how we've worked with many companies and researched them as well about their architectures within AWS. On the left-hand side, we have our sources, systems, operational systems, user files, SAS files, external data. We have it going through a direct connection, and here we have it coming up through the bottom in AWS, where a service like Amazon Kinesis will take a streaming data input Data pipelines can then be built off of that with Amazon service for data pipeline. You can incorporate Amazon Lambda functions. And then you even have, we include Amazon Glue here because it's a combination of data pipelines as the modern data integration approach to be both streaming data pipelines as well as our batch-oriented pipelines, which Amazon Glue supports. So throughout these mechanisms, we can be acquiring and ingesting data and bringing that up into the modern data platform on AWS. AWS has lots of great services for doing this. For our reference data class, what we find most often and what we recommend is using the Amazon RDS Aurora. Typically, it's the Postgres version because it is a relational database, enterprise class, and highly scalable. I believe it's quite comfortable, above 50 terabytes in storage, which is usually plenty of space for storing enterprise data and mastered reference data. For the analytics optimized class, we have Amazon Redshift. Of course, that's our MPP columnar database, and it is Amazon's fully managed data warehouse service. Spectrum that can access data that's external from the database within the S3 simple storage data lake. And then they also have the Amazon Athena engine, which you can use to query those files in the S3 data lake as well. And then the third category there we have in our flexible processing class, we go to Amazon's S3 to make that our data lake. We will have buckets that are organized, and there's a lot of architecture involved in data lakes, of course. And here is where we have our raw data buckets, our curated data, process data, in-processing data sets, secure data sets. But that architecture is the foundation for all the data that things can be built into Redshift or RDS as well. So as you push up, and as we have users now on our right-hand side wanting to come into Amazon and connect to and start to leverage and connect to this data and really do some analytics work, they will come into their own VPC where we'll have an Alteryx server installed. This Alteryx server, as a simple install setup, will be running on Elastic Compute, an EC2 server, along with Elastic Block Storage. And there is a predefined recommended configuration from Alteryx on how to get your server up and running very quickly and start accessing data in all of this modern data platform on AWS. You can also set up a simple S3 endpoint so Alteryx is able to read and write right back into your data lake. So here, Alteryx would be able to connect to data in the data lake, Amazon Redshift, or Aurora, both reading and writing output data sets. Now, on the right-hand side for data science and AI, Amazon does provide EMR service for their Spark capabilities. And, of course, Amazon has their own machine learning service there if you'd like to use that. And if you pay close attention to the Alteryx blogs like we do, we also know that Alteryx has coming up a connection between the Alteryx server and Spark so that Alteryx will be able to run some of their workloads within Spark, which is quite exciting. So here is how we can take a look at the overall modern data platform as it relates to the AWS platform and how you would run it on AWS. The bottom right-hand corner, we also include that some companies include Glacier archive storage there. It's a nice place if you've got some long-term or some data that you can pull off out of your platform from time to time. So from here, what we want to do is then talk just a bit about how do we operationalize Alteryx on AWS. One of the key components here is that with that, I said the easiest way to get up and running is to go ahead and deploy an Alteryx server in your VPC. But what we're talking about in a lot of these companies is enterprise class, which means all the users in the enterprise, as many as possible, will have the capability to do data analytics self-service mode. So you're going to need to scale the Alteryx server at some point in your maturity and growth. And this is really great on AWS because Alteryx has the controller, the worker, the gallery and database component. And each one of these can be broken up into their own EC2 groups. If you need to spread out your workload and grow that, you can take the worker component, install it on as many EC2 servers as you need. It's elastic and on-demand, the great part of AWS, or you could put this in an auto-scaling group if needed. The gallery, where people can come in and access and reuse data sets, can be replicated across multiple EC2 servers, and then you could put an Amazon Elastic Load Balancer in front of that for allowing people to have great performance and connecting to as many copies of the gallery as possible. And then, of course, if you need your database within Alteryx to grow, it comes with SQLite, but it also comes with MongoDB, which on AWS, you can start to operate a MongoDB cluster of EC2s. Now, equally important performance and scale is going to be resilience and fault tolerance. So, of course, in architectures on AWS, we recommend a minimum of 2 availability zones within AWS and within that region, and you can go up to 4 if you need that in the same region. Just check your AWS regions to see that they support 2, 3, or 4 availability zones. You can do your disaster recovery or your DR across multiple AWS regions, and you can set up active-active or active-passive replication if you need to account for disaster recovery within your architecture. And then with the S3 storage in the data lake, you can also rest assured, by the way, that the data contained within that stays within the region by default. This is actually an important concept for data sovereignty. So from there, let's go ahead and that's a lot to take in, and you've got the slides here, of course, to follow up with. But really, our point is, how do we enable the modern analytics lifecycle on this platform? So here are the 7 steps that we have seen in companies, maybe slightly different name or terms, but repeatedly, when business people go to tackle challenges in the business, decisions, hypotheses, inquiries, this is the approach they take. Number 1, state the business need. To understand and explore the decisions you're trying to make. And why this is important is because it sets up the context in which you're going to go discover data, connect to data, prep it, and build models. And it is actually quite important to be explicit about this up front so that you know how far to take your analytics. You know what's in scope or out of scope. What's the purpose of your analytics as you go to step 2, where you discover what data you have available. You know, catalogs are a great place to start here. Is this context? Do I need to upload my new data sets? Number 3, connecting to those data sets, explore them, profile the data, and then really check out, is this data applicable to the business problem I'm trying to solve, or should I be looking at a different data set? Number 4, the heart of data prep, of course, is that ability to take in these multiple data sets, to enrich them, to cleanse them, then to integrate and transform data and create the output data set that we need for either analytics, reporting, data visualization, or input into, here, step 5, for building analytic models. So when we want to develop our analytic models, we set up that base, which is a lot of time and effort by data scientists, but ultimately they're all about building their analytic models, multiple models, testing, developing them. And then from there, we go into step number 6, to visualize this data, to communicate our output, to collaborate with others and get feedback and validation as part of this process, and also to govern. This is where governance is built in throughout this whole profile, where we're going to say we want to govern this. Where should this analytics output go? Where should these analytic assets go? And then finally, we don't want to forget about the importance of properly deploying and operationalizing our analytics, monitoring these new analytics in production, make sure they're performing well, making sure everything is production hardy. So from there, why don't we go ahead and take a quick look now at what that looks like on top of AWS. So if we take the top portion of our AWS architecture and we want to put this in action, these are those steps. Number one, stating the business need in the business. Number two, discovery in the analytics server inside of your DPS. Number three, connecting to data sources, right? This is the Alteryx Designer product on the desktops, working in conjunction with perhaps Alteryx's new Connect module. Data prep happens up top on the desktops with the Alteryx designers. Number five, analyzing and building models. So this can, happens up on that desktop where those data scientists are working and analyzing, visualizing those outputs, right, for users and in the gallery. And then number seven is to deploy this. Do we want to make these APIs available? How do we productionalize this? And that happens once again at the Alteryx server within AWS. So with that, you can see how we have a data platform, we have the modern analytics lifecycle, and how this can operate very, very efficiently with the AWS services once you've brought your data and your platform into AWS. So as a quick key takeaway from what I've been presenting and talking about here, we talk about how modern data platforms are architected to deliver enterprise analytics, and enterprise analytics includes, as a core competency, self-service data analytics, and those in complement and enhance your BI development work and your data science development work. And then finally, how AWS enables a very robust and a very agile modern analytics lifecycle to deliver analytics value, time to insight, and does it at the enterprise scale. And so that's why I wanted to share today, which is our research in the field, working with companies that are developing this and running this on AWS with you. So what I'd like to do right now is turn this over to Hasan and let him show you Alteryx in action with some of the concepts that I've been discussing here. So Hasan?
Thank you, John. Then go ahead and share my screen, and then we'll go through this step by step. Okay. Make sure I'm sharing the right screen. Just 1 second. All right, perfect. All right, so what you're looking at on your screen is the Alteryx Designer, and it's really going to allow you, it's a desktop software that's going to allow you to connect to these different sources, as John mentioned, and then do your, start to bring all these different data sources together, and then to develop that big picture, and then feed into doing things like advanced analytics, spatial analytics, even predictive analytics. And really the way to do that is you drag and drop tools from the tools palette up here onto the canvas. It's a very visual platform that's going to allow you to kind of also self-document the workflow, the process as you build it out. Let me go through some of the tools, give an overview of what the Alteryx Designer looks like, and then we'll dive in and build a workflow together. So in terms of the tools are grouped by functional areas. So there are tools to input and output data from your workflow, and then we will use some of these tools to connect to, let's say, our Redshift cluster and bring in some information. There's tools to prepare your data. So depending on what your data looks like, there might be things you need to do, whether it's data cleansing, whether it's filtering your data. And then once you have done that, you can now join these disparate data sources, regardless of where they came from and where they live. You can start joining them and then into a single data set that will help you drive your data analytics to the next level. There's additional tools to do things like spatial analytics. There's tools to allow you to do data investigation. So before you dive into predictive, you want to understand the variables, you want to understand correlations, and there's tools to do that. And then let's say you want to build a predictive model and try to predict something like we're going to do today. We have predictive models pre-built for you, no reason to go and and learn R. The R code is available for you to examine and even modify and save it as your own. So it's white box. You can open it and look at it and modify it. But you can do things like predictive analytics, A/B testing, time series, market basket analysis. There are additional tools to allow you to connect to data. And we're going to be using the S3 connectors today to connect our data. But your data could be living in the cloud and really in the multiple locations. You can even use a download tool to call an API or call connector data that's not listed here. As we drag and drop tools onto the canvas, this white space here, the results of our work will show down here in the results window. And the configuration window on the left allows us to configure each of the tools that we are going to use. Now, let me give you a sneak preview of the workflow that we're actually going to create together. We're actually going to be able to achieve this within the time allocated. And what you notice is there's documentation that I added to my workflow to explain every step. And this is kind of the visual self-documenting aspect of the Alteryx workflow. We are going to grab some data from Redshift, from S3, run a predictive model on it, and then output our data back to the data lake. So we're going to go ahead and I saved that workflow, just hang it onto the documentation in terms of the steps that I need to do. So we are going to pretend, let's imagine that we are a healthcare organization. We're a very large organization. We serve a large community, many members, and we have offices and labs and technicians all over the regions that we support. And we would like to look at our community, our membership, and try to predict the likelihood of a member or a group of members or developing diabetes. And then if we can predict that likelihood, we can reach out to them in with educational programs, maybe medical, maybe just pay a little bit more attention to them in an outreach format so we can better serve our clients. So we can build a workflow together to predict diabetes risk in our community. And some of the stuff we're going to do, the first step is we're going to input data from our Redshift cluster. You can see the documentation here. I left it there for, on purpose. So you can see how we're able to document a business process. Which is a way to capture metadata about the tribal knowledge that's within our healthcare organization. And then I use that as a kind of a catalog to figure out if I want to connect to patient data, what is the best source of truth? What is a trusted source for patient information? I found out that Redshift is the patient information that everybody goes to. So I'm going to go ahead and then drag and drop an input data tool from my favorites category. It's also under the input category here. I'm going to bring an input data tool and then go ahead and configure it to point to my Redshift instance. So I'm going to go ahead and, I can connect to a flat file. I can connect to a database. So really, once I connect, I create a connection, it gets saved under my existing connection. So I'm going to go ahead and select Redshift here. And I'm going to go ahead and navigate over to that table that everybody's telling me that is a good table to use for patient information. All right, so I click refresh here just to get a quick overview of what that looks like. And then now I'm in business. What I would like to do before I proceed with this workflow is maybe I want to get a quick profile or health check on this data before I invest time, working on data and then realizing maybe there's some issues on it. So I'm going to go ahead and drag and drop a browse tool here. And I'm going to run this workflow to process this information. The browse tool is really important in allowing me to examine each of the columns that came in. I can actually click on the different columns, see a graph here of the spread of the values in that column. So if there are any issues in terms of outliers or missing data, I can right away, detect that. This is an interactive chart. I can actually zoom in to examine my data. So it looks like my data is okay. So I'm going to go ahead and proceed. One of the things I'm going to do, I did notice that the smoke indicator is coming in as a text. So I'm going to go ahead and change it to numeric so it doesn't cause problems for me in my predictive model. So I'm going to bring a quick select tool here, connect it like so, and then I'm going to go and change this smoking status indicator just to be a numeric type so I can use it later. Okay. So that's my patient information. Another thing to help me build that picture of, whether somebody's going to develop diabetes or not is I need diagnosis information. about my patients. And then that lives in my data lake because I have all these different offices in my regions, and as they get these diagnosis information, they just push it out to S3. So I'm going to be able to get it from S3 and then actually combine it to my patient data. So I'm going to go ahead and then bring an Amazon S3 download, and that's going to allow me to specify an AWS access key, a secret, and then I'll be able to connect to my S3. So I'm going to go ahead and use, just for the magic of copy paste, I'm going to use this connection I have here as not to reveal my secret S3 key here. So I'll just go ahead and I copied and pasted this S3 download tool. I provided the access key, the secret code that was given to me by my admin. I'm going to go ahead and select what is the bucket that I'm going to connect to. I'm going to connect to my HH bucket that I set up for this demo. I'm going to go ahead and select diagnosis data from that bucket. Okay, and that's probably all I have to do in terms of the S3. What I would like to do now is actually combine my patient information coming from Redshift with my diagnosis information coming from S3. So I'm going to bring a join tool. And by the way, that documentation is there as well. So if you're trying to follow along, I'm going to bring my S3 tool. I'm going to go ahead and say, okay, stop being so sticky. I'm going to have this connect to the left. It really doesn't matter which side it connects to. It's just visually pleasing when they connect like so. And then I'm going to go ahead and join on patient ID coming from the left and from the right. So I'll go ahead and select patient ID and new patient ID. I don't need that column repeated twice. I'll go ahead and deselect one of these, new patient ID here. So I don't have duplicate columns. So if I click run, it's going to bring in my Redshift data. It's going to bring in my diagnosis information from S3. And now I'm going to have a combined data set. I can look at what's matched by clicking on the inner join coming out of the join tool. And I can see I now have my patient data paired up with my diagnosis data based on the patient ID. Another piece of data that I need is as these patients go out and then they get lab results and they get tested, their lab results, depending on what lab they went to, it gets pushed up into my S3 instance as well. So I'm going to go ahead and just reuse this component again. And then I'm going to now connect to my lab information. So I'm going to be in the same bucket, the demo bucket that I set up for this, but I'm going to go ahead and point it to make sure I bring in my lab results. And this is really a convenient way for me sitting here to really connect all these different data sources and then have access to this data from all my different lab locations, regardless of where they are pushing it from. And if I just run this real quick, just to take a quick look at my data, I'm going to notice that I have some results in my lab results that may not be final results. So I have the status column here. And I'm going to go ahead and filter on final results only because those are really the ones that I want to consider in my predictive model. So I'm going to bring a filter tool here very quickly, and then I'm going to select status. I'm going to say equals final. This way I'm getting only the final results. Also, I have a column in here that shows me whether results are abnormal or not. So I'm going to go ahead and get kind of a summary information. This one I'm only counting the abnormal. There's also that were not, they were suspicious or things that I need to pay attention to, namely my abnormal results, lab results. So I'm going to go ahead and select the patient ID as a grouping field, and I'm going to say for that particular patient ID, let me know if they have, what's the maximum number, let's say, of abnormal results that they had. So I'll just say is abnormal and get the maximum out of this. And I'm going to go ahead and run this workflow now. One more thing I need to do, I do need to change the patient ID in here from a double to a string, so I can join it back up to my data set on top. So that's just a small, if I don't do it, I'll get an error in my join saying that you cannot join a numeric field to a string field, and I'll be able to recover from that, but wanted to go ahead and do that. So what I'm going to do next, I'm going to take this lab information that I've extracted from S3 down here, that I pointed to in S3. I'm going to go ahead and join it to the rest of my data that I have so far. I'm going to bring another join tool. I'm going to put it here, I'm going to take my lab results, join it to connect it to the right input, and I'm going to take the diagnosis patient information, that's the inner join from my previous step, and I'm going to go ahead and join all that together. I can run this. Oh, I haven't selected what to join on, so that's going to complain. So I'll go ahead and select patient ID from the left and from the right, and I'll remove a duplicate field here. While I'm here, I'm going to go ahead and do something else, because I do want to create a kind of a left outer join, because what if I have patients that were diagnosed, but they haven't gotten the lab results too. So I don't want to only grab the patients that have lab results. So I want to also get the patients that they haven't had time to go to the lab yet. So I'm going to go ahead and, not a join, I'm going to go ahead and bring a union tool here. And then I'm going to bring everything that joined, but also give me all the patients. So that's effectively going to create a left outer join. I feel comfortable now running the workflow, knowing that I'm getting all my patients with their diagnosis, whether they got the lab results in or not. I think I ran this. Let's see. So the next thing I want to do, I'm going to go ahead and look at my data here. I do have a problem with one of my variables where it's coming over as null. So I'm going to go ahead and clean that up. I'm going to bring a cleansing tool. And again, depending on what data quality or data issues you have, the data cleansing tool is a really good way to go ahead and clean your columns. You can do things like replace nulls with zeros, remove any unwanted characters. I'm going to take that as abnormal value from here, and I'm going to say, if you see a null there, just in case that data is not there, just go ahead and replace it with a 0, and that's going to help me clean up my data. Now, I think I have a good data set here. What I would like to do is create a sample that I'm going to use to feed into my predictive model. So I'm going to create kind of an estimation and evaluation sample so I can train my model and then go ahead and score it. So I'm going to go ahead and use the create sample tool by connecting it to my cleaned up data from the cleansing tool. And here I can decide what these percentages are. So you can have an 80-20, you can have whatever kind of mix. You can have a whole section if you want. I'm going to do 50-50 just to keep it simple, but you can specify these values as you wish. And then that's really going to get us ready to go into the next step, which is getting all of this data. I'm going to go ahead and run this as we speak. Getting all this data and then feeding it into a logistic regression model and deciding, okay, based on patient information, diagnosis information, lab results, what is, among my members, among my community, who is likely, and what is the likelihood of them developing diabetes. So I'm going to go ahead and then drag and drop a logistic regression model. So this is a binary situation where, they're either going to develop diabetes or they're not going to develop diabetes. Let me go ahead and connect the estimation output from the create sample to my logistic regression. In terms of, as far as my model is concerned, I need to give it a name. So I can just call it diabetes. And then I'll get the right checking here, the right spelling. And then I'll just go ahead and need to specify what is the variable that I'm trying to predict. And that's the variable that exists in my data set, and it's called the DM indicator. So I'm going to go ahead and select DM indicator. And then also I'm going to select which predictive variables do I think are important to this prediction. This step is really important. This is going to involve, business knowledge of the situation. Also, if I've done any data investigation in terms of a correlation or association analysis, then I can figure out which one of these variables are important to that prediction. I can also run some reports to show me the relationships. So I'm going to select a few here that I think are important. I think I have about 8 or 9 that were identified in this data set. So I'll just select a few of these. Here's my 10 variables. You can see them here, and I think these have an implication or an influence on that predicted variable that I'm trying to predict. I'm going to go ahead and run this workflow, just have it process all this data through a logistic regression model. What comes out of the logistic regression model are 3 outputs. I'll just let it finish. There's the interactive output, the report output, and the actual model output that we're going to use to actually get the output from this model to feed it into something like a score tool, which is what I would like to do next. But let's go ahead and examine these outputs from the model. So speaking of the outputs, let's go ahead and speed it up a little bit. So the interactive output is going to show me metadata about my model, the accuracy, the precision, the recall. I get some graphs here that I can see what is the performance of the model, and I decide if I need to modify anything. The report output is going to tell me the relationships between the variables that I selected and the variable I'm trying, my target variable. And I can see the strength of the relationship. I can also see the direction of the relationship. And once you decide, okay, this is a fine model, I'm going to use it, I'm going to go ahead and use the O outputs from the model to go into a score tool. So I'm going to go ahead and drag and drop a score tool, connect the outputs from the model, and then also connect the valuation to the other end of the score tool. What is the score tool going to give me is really a probability or a percentage representing the likelihood of that model, of that patient developing diabetes or not. So I'll be able to kind of have a numeric value of that likelihood. So we'll just give this a second to run. So I'll show you what comes out of the score tool, and then we're going to do a little bit of filtering to actually go ahead and filter my data. All right, looks like I lost my mouse here. All right, there we go. So coming out of the score tool, I now have a column of a score 0 and score 1 representing the probability, the likelihood of this patient developing diabetes or not. So I can go back here and I can say, okay, now let's go ahead and drop formula tool, and then maybe I'm going to put these scores into buckets. So I'll go ahead and attach the formula tool, and really for the sake of time, let me go ahead and copy this if statement from my existing formula tool here. And then what that formula is doing is saying if the patient has greater than 60% likelihood of developing diabetes, then put them in a high bucket over here, else put them in a medium bucket, else they go into a low bucket. And I'm going to go ahead and add a filter here. I'm going to say, you know what, just filter out those fields, those customers where the bucket is high. So now I have the patients that are most likely, or they fit in the high bucket. What I can do from here is really up to my business needs. What do I need to do with this data? I can definitely send it back out to my S3 data lake. I can build a static report. I can refresh a Tableau server. If I have a workbook that's showing this information and I want to go ahead and refresh that workbook, I can do that. So let me go ahead and then maybe go ahead and send this out to an S3 instance. So I'll just copy this over here. I can also create a static report using our reporting mechanism. I'm going to go ahead and just borrow these tools from here and then just paste them there. What this is doing is saying, okay, take this data and then go ahead and send it out as a static report. So let me see if I can get both of these to come over. And the reason this is important is because sometimes you want that visual confirmation of, okay, here are the results, I see them, maybe you can save that off and send it to somebody. Sometimes you want to send this to just update a database. Sometimes you just want to maybe refresh some kind of visualization that you have. So there you go. I think I got this right. We'll just run this workflow. So when I run this workflow, effectively what it's doing is bringing all these data sources together, Redshift, S3, and then feeding all that into my logistic regression model and updating my data lake with the patients that are most likely to develop diabetes. And the last thing I want to do is, if I want to take this workflow to the next level, I do have an instance of Alteryx server running on EC2. So I can actually go ahead and then deploy this to the Alteryx gallery, also running on EC2. And then what that's going to do, I'll just call this live demo. Live. And then what that's going to do, it's going to give me a web interface that I can run this workflow from. So now this is running in the Alteryx server running on EC2 with the web URL. So I can actually have users come in here and then they have that URL, even without having Alteryx or licensed Alteryx software, they can actually now access this application. This is Alteryx workflow running behind the scenes, you can see, and then now it's going to run that logistic regression and present me with the results back right here onto through the web interface. And you can see the results. These are the top. You can see the bucket is high. These are the top clients, members that I have, the most likely to develop diabetes. I can take this, save it as PDF, as a doc, as an Excel, and because I built my workflow to actually also update my data lake, that information is now also published to S3. Thank you for your time. I think I'm going to go ahead and turn it back at this point. Thank you guys so much.
Thank you for that, Hasan. And with that, I'd like to once again thank John and the entire Radiant Advisor team for that great research, as well as Hasan for that great demo. I'd also like to thank you, our audience, for tuning in today. As the next step, please download your 14-day free trial of the Alteryx Designer. With the kit, you'll get pre-built Alteryx workflows, making it that much easier to get your hands-on experience with the platform. A follow-up email containing this URL will also be sent to all webinar attendees as a follow-up. And with that, I'd like to hand it back to you, Bill.
Well, Raman, Hasan, John, hey, thank you for that excellent presentation. And we'll get started with today's Q&A session. I want to thank the audience for their participation. We've had a lot of questions that have come in during the presentation, so we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'll leave up this screen with contact information for Raman, Hasan, and John in case you'd like to contact them following today's event. So let's get started. John, I really liked your architecture for the modern analytics lifecycle. The audience wonders, does that apply to all of my analytic programs and initiatives? And do I need to have all of those AWS components working before I can get to that level of sophistication?
Actually, that's a really good question. So for the modern analytics lifecycle, this is an approach that business analysts and scientists approach just about every problem. So it is based on that. Now, it can tackle questions that in the business they need to get their hands on the data and figure things out and do discovery on their own. But, you know, one of the things it does is really complements BI development and the BI projects that you have, empowering the business analyst to go through and flush out a lot of those requirements and analysis that goes into building BI projects. It also works the same way with data scientist projects where, you know, a good percentage of their work is going in and prepping data and organizing and understanding and building their best data set. So it does apply to, I would say, nearly everything out there as an analytics lifecycle because it's a little bit more of an organic or natural approach to working with data in general for analytics. Now, the other question you had is, what about AWS components? No. It's actually one of the things we see in architectures where the diagrams that I presented here are really end-state vision kind of architectures. This is where companies end up after a few years of their architecture development. So how do they get started? Typically, you need at least a good database. Redshift is a good one there, or a data store, depending, like S3, depending on what you're most comfortable with. And then the data streaming tends to be a maturity thing that comes in a little later with data engineering. But, you know, first you want to be able to easily get data up into the platform, Redshift or S3, and then get your Alteryx server, you know, installed quickly, and you're up and running.
Well, John, thank you for that excellent answer. Question from the audience relates back to very early in your presentation where we were talking about you had the platform team and the data management team and the data science team. And the question is, who owns or manages the data unification layer, and what does that look like from a tools and organizational perspective?
Yeah, so why don't I push that slide back out to the audience so they can know which one we're referring to. So I didn't go into it too much, timing, but there is what we refer to as a data unification layer that spans across all three of these competencies. And the purpose of this is when we take an approach where the modern data platform is in multiple databases or data stores, multiple locations, on-prem and in AWS, the end users really still psychologically need a single place to go. So in their mind, I go to this one place. What are the capabilities needed in the data unification? A semantic layer, if you will. Where can I find business data, definitions, raw data, context? This is where data catalog capabilities usually live, as well as govern data sets and governance. So this is ungoverned data. This is certified and controlled data, so you know you can trust it. And then it's also a platform where people can collaborate and share all of their data in one place. So we separate out data prep onto part of that data integration layer, but usually data unification can be a combination of tools in these categories. But today what we're finding is that there is a platform approach to this. We are looking for a platform kind of tool that's capable of doing 1, 2, 3, or the most possible from each one of those capabilities. And the second part of your question is who owns that? What we find is in all of this, IT, if you will, owns building the platform, maintaining the platform that enables the business to do data and analytics. So the heart of that is still in the business. But as far as a support team and support self-service, they support tools like Alteryx that will allow the business to run. They support a data unification platform tool that enables the business to collaborate, govern, and find data.
John, thank you for that excellent explanation. Hasan, I think this next question is for you. Toward the end of your demo, you showed a very interesting feature in which you exported the model through a URL to a web interface, and the audience is wondering how often that's updated, or how do you control the frequency of updates? Is it once a day? Is that something you could specify in your drag and drop workflow?
Sure. That's a great question. So that is taking an analytics application that I built on my desktop and then publishing it to the Alteryx gallery running on top of the Alteryx server. So once I publish that, it's now under version control. So my users will see that the users I give permission to access run this workflow, they'll be able to see that copy, the latest copy of the workflow. I can go back to previous versions if I want to go ahead and modify it, and then we'll release a new version. I do another save as up to the gallery, and then that copy is refreshed. Again, everything's under source control, and as an admin, I'm able to go back and revert back to an earlier version of that application. But that once I publish that copy of that workflow is live, and then my permissioned users can see and run that workflow.
Okay. Well, thank you for that. John, we don't have a lot of time left, but there's a really interesting question here about folks that don't have big teams. What is the simplest version of all of this that they can employ and still get something that approaches your modern analytic lifecycle?
Yeah, that's a very good question. There's a lot of small teams, limited resources out there, and I think the real point here is it doesn't take a lot to get going and get started. Remember, with Alteryx or other kind of data self-service, data and analytics tools, the goal here is to get something up and running and support it, which only takes 1 or 2 people, that then enables the business to do this. The business analysts, many of them out there, your power users, your data scientists, your citizen data scientists, they are the users that are coming in. So in order to do this, what we're looking to do is to say, hey, here's your place to go, and we've managed to connect these databases for you, and it really enables you to have a platform to go forward and do this work.
Well, John, Raman, Hasan, thank you so much. Those were some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Raman, Hasan, and John and the Alteryx team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for March 28th. That's our next DSC webinar. By the way, that's tomorrow. And that'll be presented by Databricks, and the title of that will be Data Contributions to a Conversational AI Platform. Well, also please remember that today's taping will be available on demand for viewing later today, and you can find that on the home page of Data Science Central, and that'll be in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Alteryx for their sponsorship, and particularly to our speakers, Raman Kaler, Hasan Hboubati, and John O'Brien for their insight into today's topics. Well, this is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again tomorrow, March 28th. Have a great day.